Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today, we are going to start section 1, part B, which is where you are allowed to use a calculator. It's 50 minutes with 17 questions, so roughly 3 minutes per question instead of 2. Still multiple choice. There are 17 problems. I don't think it will take forever if we try to finish in one sitting with the explanation. So probably I will do it over 2 sessions. We'll see how it goes, but that's what I expect. Okay, so let's start with the first problem. The first problem, which is problem number 29, it says a spherical balloon is losing air at a rate of negative 24 pi inch cubed per second, meaning that's dV dt, right? The change in volume. Of course, it's losing, so it's negative 24 pi cubic inch per second. How fast is the balloon's surface area, meaning d area by dt? What is dA dt? How fast is it shrinking when the radius of the balloon becomes 2 inches? So related rate problem, of course, I have to know the volume of a sphere and I need to know the surface area of a sphere. We know that the volume of a sphere is 4/3 pi r cubed and the surface area is 4 pi r squared. Okay, so now what we are going to do is to take the derivative with respect to time, since I have inch cube per second, meaning volume divided by time. So dV dt becomes the 3 is a exponent, so it would become a multiplier and simplify with this 3, and you get 4 pi r squared, which incidentally is the surface area. That's how you remember. You can integrate that if you forget the volume. It only works for the sphere. dr dt. Notice that the dA dt, which I want to find, is 8 pi r dr dt. So once I find dr dt, I'm going to plug it in here and find dA dt. dV dt is negative 24 pi. So when I simplify, the pi and the pi cancel. The 24 with the 4 would make that 6. So when I divide both sides by r squared, I get dr dt equals negative 6 over r squared. Notice that r in this case is 2 inches. So when I come here, I say dA dt is 8 pi times r, which is 2, times negative 6, divided by r squared, which is 2 squared or 4. 8 divided by 4 is 2, times 2 is 4, times 6 is negative 24, times pi is negative 24 pi. Same number as just a numeric value, but this one is inch per second. I'm sorry, inch square per second, because that's the change in surface area. This is a change in volume. They are not the same. So when you get the same number, it doesn't mean they are the same quantities. This is a volume, that's an area, right? So anyway, here is the first problem. Where did I put the rest of the questions? I think, yeah, this should be the second, number 30. And the papers are stuck together. Okay, so number 30. When are the horizontal and vertical components of the velocity of a curve whose motion is given by x equals 5/2 t squared plus 6 and y equals 2t cubed minus t squared plus t are equal? When are the horizontal and vertical components of the velocity equal? That's a very simple problem, right? Because the velocity is the derivative of the position with respect to time. So if I want to find the x component of the velocity, I will take the derivative of the x position with respect to time. 2 and 2 cancel, and you get 5t. When you take the derivative and get the y component of the velocity, meaning this would be moving at 45 degrees if the x and the y are the same. This would be 6t squared minus 2t plus 1. And then they tell you at what t will they be equal. So you get a quadratic equation. You say this equals that. So when you move one to the other side, you will get 6t squared. The 5t, when you move it here, becomes -5 minus 2 is -7t plus 1 equals 0. Of course, since 6 plus 1 equals 7, that's an easy problem, easy factorization. You have a -1 and a -1, right? You get 6t squared plus 1, -t, -6t equals 0. So either t equals 1/6 second or t equals 1 second. Now we go to the solutions. I have a -1 and a -2, but I don't, and a 2, but I don't have a 1. I have a 1/6, which is C. Oops. Oh my God, I was doing 31, not 30. And I'm not going to do 30. Why? Because I don't know how to do it. Really? Yeah. Why? They ask you to find the limit as x approaches 0 for this quantity. And in this case, you will get probably infinity because the degree of the denominator is higher than that of the numerator, and you will divide by 0, so you get infinity, and none of these is infinity. I think they wanted you to do L'Hopital's rule. The only problem is that if you substitute x equals 0, this quantity is not 0. That would be 3. 3 to the 3/2 minus 0 is not 0. It's 3 to the 3/2. So you cannot even use L'Hopital's rule. So there must be something, again, an error. I tried to figure out how could that give me one of these answers, but I failed. Okay, so we are not going to do number 31. Number 30, I'm sorry, I kept confusing these two. I'm going to look into it and maybe I find the correct problem if I search online, but this one definitely doesn't have any of these as the answer. Okay, so when we move to number 32, in fact, this one also is wrong, but I can solve it. Wrong, and you can solve it how? Well, wrong because they tell you to find the derivative of this graph at 0.3 and 2. If you substitute 3 and 2 for x and y, you will not get 2. You will get something like 107, I think, when I tried it with a calculator. I didn't, but that won't affect. So suppose this was, when you calculate it, let's say you get 100 and whatever, 7, I think it was, or maybe some other number. So if I write equals this number, the problem now is solvable because when you take the derivative, the right-hand side would be 0 anyways, but it doesn't make sense to write any number here if it's not satisfied. You see what I'm saying? If that's x squared is 9 plus. Notice that already I'm adding, those are positive, and I'm adding 4 values. One of them is 9. So how can you add and get 2? It's really ridiculous. And I said maybe one of these is minus instead of plus. I get 1, but I can't get 2. For example, x squared we said is 9 times y is 2. So that's 9 times 2 is 18 times 3 is 54 plus 3 times 4 is 12 times 3 is 36. These are 99 already. Plus 8, yeah, it's 107. That's what I remember. You cannot divide 107 into 2 numbers whose difference is 2 because that's odd, right? So one of them has to be odd, the other has to be even. You can make 1, meaning if you add 36 plus 8 is 44, plus 9 is 53. So you get 53 and 54, of course. which are the two consecutive numbers that give you 107, so that you can say 1 and change, but it doesn't make sense. So let's say equals 107. It really doesn't make any difference, but it makes the problem correct. You see what I'm saying? Because now it's not correct. Okay, so let's say number 32. I want to find the derivative at that. So notice that this is explicit differentiation because you cannot separate the x's from the y and say dy dx. Okay, so I'm going to take the derivative of x squared is 2x, and you have to be careful in the next one because you have 3x squared y. X squared y is a product now. So you say the first, which is 3x squared times the derivative of the second, plus the second, 3y times 2x, so 6xy, just to save time. Plus, again, I take the derivative of y squared, it's 2y, y prime. So 2 times 3 is 6xy, y prime. And then you say 3y squared times the derivative of x, which is 1. So you get 3y squared. And finally, you get plus 3y squared, y prime equals 0. And now I'm going to keep the y prime terms to the right and the constant to the left, and then divide both sides by that value to solve for y prime. So here I have 3x squared. I have plus 6xy, and then plus 3y squared. When I move the others, okay. When I move the others to the others, I have a negative sign because all these three terms would be negative. So negative 2x plus 6xy plus 3y squared. And now you substitute with 3 and 2. So 3x squared, x is 3, so that's like 3 cubed, which is 27, plus x times y is 6 times 6 is 36. Y squared is 4 times 3 is 12. Of course, you can use a calculator, maybe faster. 2x is 6. Xy is 6 times 6 is 36. Y squared is 4 times 3 is 12 again. So y prime equals, this is 48.75, and this is 42.54. I can simplify by 3, that would become 25, and that's 18. So y prime equals negative 18 over 25. Yeah, that's D, negative 18 over 25. That's a simple one. It shouldn't take you long. Okay, let's move to 33. 14 minutes already. Oops, why did I bring that? No, we still have two problems here on that page. This sheet, we'll do number 33. It says a kid on a bike is riding home in the woods on a straight path that is 50 meters from the nearest point on the road. So the roads, the forest and the road are parallel? Should be. His home is 1,500 meters from the nearest point on the road. So let's say this is the forest and that's the road. Of course, I'm not going to draw a road, just a line. And the distance between them is 50 meters, right? The guy is here riding the bike, and this distance from home is 1,500. If the kid rides at 3 meters per second on the forest and 5 meters per second on the road, how far from his house should he cross to get the shortest time? So should he cross at the beginning and move down at 5 meters per second, or should he move a little bit and then go cross to the street, or how? How do we solve that? Well, you're gonna assume that he's gonna drive or ride in a distance of X in the forest, then cross, then go. And you say, no, that doesn't make sense, right? He should cross, but should he cross horizontally or with a small angle or with a large angle or a medium angle? How? So what we are going to assume that he's going to cross, it doesn't matter from here or from here. What we are interested in is the distance that he would travel, no matter what X is. It's going to be, if this is 50, then this would be the square root of X squared plus 50 squared. That's Pythagorean theorem right there. So whether he starts from here or down, we really want to know, and that distance would be 1500 minus X, because he would have went X. So should he go horizontal? Probably not. With what angle would reduce the total time? So what we can say, the total time is the distance he will be traveling in the forest, which is the square root of X squared plus 50 squared divided by the speed, which is 3, because that's the time he will be riding in the forest, plus 1500 minus X over 5. That's the total distance traveled. And that's the total time traveled. So in order to find now, first of all, let's say the distance traveled, right? It's square root of X squared plus 50 squared plus 1500 minus X. And the speed or the time traveled would be the distance in the forest divided by the speed of the forest plus the distance in the road divided by the speed in the road. And we want to minimize the distance, or we want to minimize the time, right? So how do we minimize the time? You take the derivative of the time with respect to X and equate it to 0, right? Because that would give you either the minimum or the max. You would know if you take the second derivative and you get a negative number. So let's see what we get if we take the derivative dt dx. I will get 1/3, and then the derivative of the square root, first of all, it's 1/2 over, this is X squared plus 50 to the 1/2. So when you take the derivative, it becomes to negative 1/2, meaning it becomes in the denominator, and you get 2x in the numerator plus negative 1/5, and you equate that to 0. So you will get, if you take a common denominator of 15x, 15 square root of X squared plus 50 squared, this would be 5x, and that would be minus 3, the square root of X squared plus 50 squared, and you equate that to 0. Right? Let's see if this, I did this correctly. 3 times 5 is 15. The root, this would be 5x. This would be 3. Okay. So now in order for this to be 0, meaning the numerator would be 0. So 3 root x squared plus 50 squared equals 5x. I'm going to square both sides. So I get 9 times x squared plus 50 squared equals 25x squared equals 25x squared. So when I move the 9x squared to this side, it becomes 16x squared, right? This is 25 minus 9. And this becomes 22,500. So x equals the square root of 22.5 over 16. It's 37.5. Have to be careful because here they tell you how far from his house should the kid cross to the road to get home. So they want that distance, not the x. So you have to, that's why they give you 37.5 as one of the answers. So distance that we want, it's not that distance. This is the total distance, and really it's 1,500. Why did I do that? That's the total distance that the kid traveled, but they didn't ask me for that. So I have to say 1,500 minus that, which is 1462.5, which is E. That's why they let the 37.5, which is A, dangle in front of you. So some students will pick it up thinking it's the correct answer. Be careful to read the problem, what they ask you to find. Okay, now let's move to number 34. I think I'm 34, meaning we did only 6 problems. No, that's 2. Let's at least do 8 or 9. Number 34, it says a shoe company determined that its profit equation in millions of dollars is given by profit equals 2x cubed minus 105x squared plus 1,500x minus 1,200, where x is the number of thousands of pairs of shoes, and it's between 0 and 50,000. Optimize the manufacturer's profit. Okay, so in order to maximize that, we want to find the value of x that would make P maximum. So you learned already, like the previous problem, we are going to take partial P by partial x. Okay, so you get, okay, dP dx. I know you don't worry about the partial I said, I'm sorry. 6x squared, 2 times 105 is 210, x plus 1,500. All these numbers, by the way, are divisible by 6, so I can simplify, make that x squared minus 35x. 6 times 25 is 150, so plus 250 equals 0. Then you can use your calculator, find the, or you can factor, this is easy, x, 25 and 10, right? 25 times 10 is 250, and negative 25 minus 10 is negative 35. So x, either x equals 10 or x equals 25. They don't want x, they want the profit. But which one maximizes, which one minimizes? Common sense would say, take the big one. No, we don't do that. You have to take P, the second derivative of P with respect to x, and you see whether you get negative or positive. So this would be 2x minus 35, right? Because that's the first derivative. So when you take the second derivative, you get 2x minus 35. At x equals 10, you get 20 minus 35, so that's negative. At x equals 25, that's 50 minus, that's positive. So producing 25,000 pairs minimizes and produces 10,000 maximizes. Yes, because as you go higher, the x squared, this is 105x squared. And this is 10 times, but it's only x. So at one point, the x squared term becomes, in the beginning, the x squared term is bigger, but as you go higher, does it? No, because when you come here, this is the equation, I'm sorry. At small values, yeah, here at 10 is the maximum. So the P here becomes 2,000 if x is 10 minus 10,500 plus 15,000 minus 1,200. Well, we can do it mathematically. Notice that these are in millions of dollars. So 2,000 minus 10500 plus 15,000 minus 1,200 equals 5,300 million. So this is like $5.3 billion. Yeah, that's A, $5.3 billion. I bet you I didn't do it, but I bet you if we do 25, it would be one of these answers, which would be smaller. So it would be, if they use it, they would be one of these two. And many students will pick it up because they thought if you produce more, you will, your profit will increase. That's not necessarily true. Because at one point, maybe the price of the material or the workmanship or so is more than the profit you make. So you have to, that's why it's very important to learn how to optimize things. So you don't lose money by working more, right? Okay, now the next problem says if the function f of x equals x to the 4 has an average of 5 in the interval 0 to k, then k equals what? Okay, that's really easy because we know in order to find, you are at 0. So basically you are integrating the function from 0 to k of x to the 4 dx, and you divide that by the interval, which is k minus 0 or just k, and you equate that to 5. So that should be an easy one. When you integrate, you get x to the 5th over 5k, and you evaluate that from 0 to k, and you get that equals 5, right? K minus 0 is k, and x to the 4 is x to the 5 over 5, and the average is 5. So you get, when you substitute 0, would not give you anything, so you get k to the 5th over k equals 25 when you multiply both sides by 5. So k to the 4th equals 25. K squared would be either positive or negative 5, but it doesn't make sense to say negative, right? The average is positive, so you get 5, which means k, again, is plus or minus root 5, but it's just square root of 5, which is b. That was an easy one. If you know the definition of the average, then you get it right away. Okay, number 36. Oh my God, what is that? Integral of 3x times 7 to the 3x squared plus 2 dx. What? Okay, remember, when you have something that has a power and the derivative of the power is a multiplier or a constant times a multiplier, You definitely use a u substitution. I wouldn't, but as I always say, but we say let u equals 3x squared plus 2. So du becomes 6x dx. I have 3x dx. So I can write it as 1/2 times the integral of 7, 3x squared plus 2 times 6x dx. I just moved it so I can see that this whole thing is du. So I get 1/2 times the integral of 7 to the u du. How do you find the integral of 7 to the u? It's 7 to the u divided by natural log of 7, right? Do you know how to do it? If you don't, what do we do? Anyone knows how to do it if you can't remember which way it is? Notice that if you are in trouble, and if you have something like that, 7 to the u, you can always, no matter what these two functions or one function is, you can always write it as e raised to the natural log of 7 to the u. Do you see that? And that becomes e raised to the power of 4 natural log of 7. Oh, I'm sorry, u, I said 4. And how would you integrate that? You integrate e to the any power as the same as e to the same power, right? And then you divide by the multiplier of u. So you get e to the u natural log of 7 over natural log of 7. But e to the u natural log of 7 is what we had before. It's 7 to the u. So I worked around it to get that, but most likely you already know when you integrate 7 to the u, you divide, and if you take the derivative, you multiply. But anyways, so that becomes 1/2 7 to the u over natural log of u. But u is that, so I have to write it as 1/2 or 1 over 2 natural log of u of 7 to the 3x squared, don't forget about the 1 now, plus 2. And then we learned that if you have 7 to 2 functions added, so you can say this is 7 to the 3x squared times 7 squared over 2 natural log of u. 7 squared is 49. But notice here I don't have any 7. So 7 cubed, if you use your calculator, becomes 343 raised to the power of x squared, right? Because this is 7 cubed to the power of x squared, and you know the power becomes a multiplication. And that becomes your answer because all of these have, and that should be b, of course, you add a constant. You have b 300, no, that's not b, that's a. 49 times 343 to the x squared over, oh, I said u. No, it's not a natural log of 7. And you say, oh, but that doesn't have natural log of 7. Yes, because 2 natural log of 7 is the same as natural log of 7 squared, which is natural log of 49. So this can be written as natural log of 49. They make it so complicated, but it's to test your knowledge of natural log. 49 times 343 to the x squared over natural log of 49, so that's a. That is a little tricky, but not hard, especially if you know how to integrate 7 to the u, or 7 to anything, or any number to x or a power of x. Okay, let's do 37. I think we stop here. That would be, we did 9 problems. One wasn't working. So basically there are 16, and this would be the 8th. So we can stop after that, I think. Yeah, we took 35 minutes already. Number 37. It says a rectangle with one side on the x-axis has its upper vertices on the graph of y equals cos x plus 1 between negative pi and pi. So we know that cos negative pi or pi is negative 1. So when you add 1, you are at the 0. When you go up to 2 and then back to 0. And then you want to draw a rectangle. Did they say? What is the minimum area between the rectangle and the graph? Meaning I want to minimize these 3 regions between negative pi and pi. This is 0. So basically that would be x and that would be x. And the height is the function, which is cos x plus 1. So how do we minimize the area, meaning maximize the rectangle, the area of the rectangle, right? What is the area of the rectangle? The area of the rectangle is the base is 2x. Area of rectangle is 2x times cos x plus 1. And the area here of under the graph, so area cosine equals the integral from negative pi to pi of cos x plus 1 dx equals sine x plus x evaluated from negative pi to pi. Sine pi is 0 and sine negative pi is 0. So you get pi 0 plus pi minus 0 minus pi equals 2 pi. Okay? I want to maximize this area. To maximize this area, I'm going to take the derivative of the area of the rectangle with respect to x. So dA dx equals. Let me write this as 2x cos x plus 2x. So when I take the derivative, I get negative 2x sine x plus 2 cosine x plus 2. And I'm going to equate that to 0. So really, I can use my calculator here. I cannot do it without a calculator. So I'm going to draw this graph and find its zeros, right? Okay, so I will go to y and say 2 cosine x minus 2x sine x plus 2. Wait, let's do it. Oh, I wanted to do. Let me do the window. I want to go from negative pi. So let's say negative 4 to positive 4. And then if this is 2, so I will go from negative 2 to 2. Well, so really, I can see that this would become 0 at negative pi and 0 at pi. So I want the one in the middle. So we can go to the calc and we want to find the 0, and probably to find x, either I find the negative x or the positive x. That is symmetric, so it really doesn't matter. So where is the thing? Oh, it's here. Okay, so let me make this the left-hand side, and that's the right-hand side. Oops, what happened? Why? This is the left bound. This is the right bound. Why it give me error? It's 1 point, so x equals 1.3065424. I'm gonna write that. 1.3065424. Okay. So now I'm going to find the area between, because now I maximize the rectangle, meaning I minimize the difference between 2 pi and the area of the rectangle using this as x. So I'm going to say 2 pi minus, and then I'm going to substitute the x here. So I'm going to say, let me make sure the mode is in radian. Yes, it is. Okay, so I have 2 pi minus 2 times x, open parentheses, cosine x plus 1, close the parentheses, right? That's, I minimize the area, I think so. 2.988 if I use 3 decimal places. Oh, that's B right there. B is 2.988. And that would be the answer to this problem. So in the beginning, we found the area of the rectangle is easy. We know that it has to be symmetric to be a rectangle. So to have the same height, I have to go the same distance from the y-axis, right? So that's why if this is x, that has to be x. And the height is the function they gave me, which is cosine x plus 1. So that is the area. And the area of the semi or the half the cosine function is 2 pi. So first of all, to minimize the difference, it means I maximize the area of the rectangle. So how do I maximize anything? You take the derivative with respect to x. Notice that I knew that at negative pi, this area would be 0, right? If I make a rectangle here, its area would be 0, right? Meaning if I take x negative pi and x pi, I get a straight line, and the area of the straight line is 0. So whether I take x is negative pi or x is pi, I get 0. But if I get x is negative 1.3 or positive 1.3, it doesn't matter. I will get the maximum area. Okay? Yeah, almost 45 minutes, so that's more than enough. I'll stop here, and we'll continue the remaining 8 problems in the next session. Sorry if it took too long, but as I told you, it will have to take longer because I will try to explain what I'm doing. I'm not just solving, right? Don't rush, but at the same time, be meticulous. Read carefully what they ask you, because sometimes, like we saw in the problem of 37.5 and the 1500 meter, that 37.5 is the distance, or the distance outside of the road they travel vertically. Of course, they are moving diagonally, so they move more. But what I'm saying is that they get closer to the house by 37.5, which means on the road, the guy will have to ride 1462.5 and not 37.5. Okay, Again, thank you very much for your time and for watching. If you have any questions, as usual, let me know. And I hope to see you soon. Bye.